mga kapakwan, today we're tackling elliptic geometry, which as we know deviates from our classical Euclidean constructs. It's founded on the premise that we're working on a sphere, not a flat plane.
That's right, and historically, this was a breakthrough because it helped mathematicians step away from the rigid limit of Euclidean assumptions. The idea that parallel lines met is revolutionary.
It is fascinating because it redefines straight lines as geodesic or great circles on a sphere, which naturally intersect. And this fundamental change impacts how we understand shapes, angles, and as well as distances.
A practical viewpoint, understanding elliptic geometry is crucial for fields like astronomy and GPS technology. It helps in plotting the shortest path between 2 points on a spherical surface, vital for navigation.
Exactly. And when you dive into mathematics, a triangle on a sphere has angle sum greater than 180 degrees, challenging the Euclidean angle sum property. This opened up new ways to explore geometry's influence on modern science and even relativity.
It also touches on philosophical aspect, doesn't it? So the idea that space is not inherently flat challenges how we perceive the world around us and pushes the boundaries of traditional geometry.
Definitely, Rose. And when you apply these concepts, you realize that many systems designed to operate globally, like satellite networks, rely heavily on non-Euclidean geometry principles.
To sum up, while it may seem abstract, the implications of elliptic geometry permeate both theoretical physics and practical engineering. It's a perfect example of how advanced mathematical theories are applied in real-world scenarios. Hence, we have here our watermelon model.
Great circle is the largest possible circle that can be drawn around a watermelon. If we cut a watermelon at one of its great circles, you've got it exactly in half. A great circle has the same center point as its sphere. Equator, another of Earth's great circles. If we were to cut the watermelon right on its equator, we have two equal halves, the northern and the southern hemisphere part of the watermelon. The equator is the only S-wise line that is a great circle. All other parallels get smaller as we get near the poles.
Poles are defined as points on a sphere that are diametrically opposite to each other, considered as a single point. Arc circles are one type of line in elliptic geometry, defined as arcs of circles that intersect the bounding circle at right angles.
Diagon may be constructed on a sphere or on our watermelon as a pair of 180 degrees arcs connecting antipodal points when it forms alone. A triangle must pass through the equator pole and equator. It is a part of the arc of the great circle.
Zachary quadrilateral. If perpendiculars are drawn from the extremities of the base of a triangle upon the line passing through the midpoint of the two sides, then a Zachary quadrilateral is formed. Lambert quadrilateral can be constructed from a Zachary quadrilateral by joining the midpoint of the base and summit of Zachary quadrilateral.